Hi again, Chem 203. We are going to perform today the third experiment of our course, which is the oxidation-reduction titration. The first part of our experiment is the preparation of our titrant, which is the KMnO4. I'm going to weigh first 1.6 gram of this product. I don't need the weight of the weighing dish, so I tare it, and I take some granules of KMnO4. I will take 1.6 gram of them to prepare the titrant that I will standardize later on. The weight must be approximative because I'm going to standardize the solution later on. Okay. Now I have 1.6 grams of KMnO4, which I have to prepare a solution of them in a volumetric flask of 500 milliliter as capacity. So I'm not allowed to pour them directly into the volumetric flask. I have first to dissolve the granules in portions of 50 milliliter. So I add my compound into a small beaker, and I try to add 50 milliliter and get all the granules from the weighing dish. I shake like this. I have to stop few seconds to let the solution and the undissolved granules precipitate at the bottom of the beaker. Then I have to decant. Decant means I have to take the supernatant solution and with the dissolved granules and put them inside the volumetric flask. Then, as you see, I have lot of remaining undissolved granules at the bottom of the beaker. That's why I have to put again almost 50 milliliter of solvent, of water, which is the solvent. Almost 50 milliliter. I stir again. And decant again. Again, a little bit still undissolved granules. That's why I have again to put 50 milliliters of water in the beaker. I have to let for precipitation few seconds, then I decant a third time. few undissolved granules at the bottom of the beaker. So again, I take 50 milliliter of water, this time I must be done, and I take all the liquid. Okay, I rinse the beaker with little distilled water to be sure that I took all the way the amount of KMnO4. Okay. Now I have to shake a little bit. Then I have to fill the volumetric flask till the mark with distilled water. Again, when I get close to the mark, I have to stop and continue by adding water with a dropper till the mark that I have the bottom of the meniscus tangent to the mark. Now I have a good mark with 2 more drops. Okay, that's it. Now I have to homogenize my prepared solution. I put the cap like this. I have to invert it 1, 2, and 3. Now I am sure that I have a homogeneous solution of KMnO4. This is the first part. Now we start the second part of this experiment, which is to weigh 2 masses of sodium oxalate to standardize the KMnO4. I will start with the first mass. I note the dish as M1. I put it on the balance and I push stir. I open the bottle of sodium oxalate. So this is M1. I have to note M1 as 0.272 grams. I remove it. I note a second weighing dish as M2. I push stir. I close the chemical bottle. Every bottle I use, I have to close it well after usage. And I have to note the second mass as 0.262 grams. Now I have to prepare some solution of this oxalate with a 0.1 molar of H2SO4, but I just have a mother solution of H2SO4 1 molar. So what should I do to have 1 liter of H2SO4 0.1 molar? This is H2SO4 1 molar. I have to prepare H2SO4 0.1 molar. That's why I have to do a simple calculation where I found that I have to prepare of the mother solution, I have to pipette from the mother solution of H2SO4 1 molar 100 milliliter and diluted into a 1 liter volumetric flask to mark to have my needed acid. That's why I have prepared into the volumetric flask some amount of water, because I never add water to acid. I'm going to add a concentrated acid to water to have my solution. Now I have to pipette 100 milliliter of H2SO4 1 molar. Now this pipette is not able to pipette in one time, in one shot, the 100 milliliters. So I have to refresh its capacity by pushing here and there at the same time, in order not to lose the whole amount that I have pipetted. Again, I will refresh the pipette capacity. Again, 100 milliliter is relatively a high amount for a pipette and a pipette, because in a lab we work with few milliliters. That's why I am obliged to refresh the pipette many times to get my 100 milliliter. I am almost done. The bottom of the meniscus of the liquid must be tangent to the mark of the pipette. So now I have exactly 100 milliliter. I have to transfer them without losing any drop of liquid, and I have to transfer them into a volumetric flask that contains some amount of water. I'm adding acid to water. 1 molar H2SO4 is considered to be a concentrated acid. Not too much, of course. We have more concentrated acid. I used a pipette and a volumetric flask to prepare a well-defined concentration of the acid. I didn't use a graduated cylinder or a beaker. I never prepare a well-defined concentration of solution into a beaker, into an Erlenmeyer flask. This is wrong. I have only to use a pipette and a volumetric flask to get a correct and exact concentration of acid. Now I have to continue till the mark. I have prepared 1 liter of the needed concentration of acid, because later on I will need 3 portions of 250 milliliter of this acid, 2 for the standardization step and 1 250 milliliter for the unknown weight of sodium oxalate that I will titrate later on. I will continue to the mark with a dropper. This is a step of diluting a concentrated acid. What I'm doing now is the preparation of a dilution of acid. I'm diluting the H2SO4 from 1 molar to 0.1 molar, so I'm diluting it 10 times. Now I reached the mark. I have to homogenize my solution. I have to invert it. 1, 2, and 3. I have now a homogeneous solution of acid H2SO4 0.1 molar that now I will use. Why I prepared this acid? I will use it to get 2 portions of 250 milliliter of acid to dilute my sodium oxalate. I don't transfer from the volumetric flask to the graduated cylinder. I will take 250 milliliter from my diluted acid by pouring it into a beaker. Now I am using a graduated cylinder to get my acid because the volume of this acid will not be introduced into my later calculation. This is only to have an acidic medium to do the titration inside. Now I will prepare my sodium oxalate. This is M1. I will pour it into an Erlenmeyer flask to do the titration, and I will get all the granules with my 250 milliliter of acid. Now I am sure that I got all the granules that I have weighed on the balance with my 250 milliliter of H2SO4 0.1 molar. This is M1. So I will label the Erlenmeyer as M1 or 1 and put it aside. I will do same for the second weighed portion of sodium oxalate. I will get 250 milliliter of H2SO4. I will get all the granules. and I note this Erlenmeyer as 2. Now, done with the second part of the experiment, I will go now to the standardization step. I have to fill the burette with my titrant, which is KMnO4, to start the standardization. I fill in a small beaker the KMnO4. I have to wash the burette with some amount of distilled water 2 or 3 times by putting a waste beaker under the burette. Then I have to wash the burette with little amount of my titrant using a funnel. I rinse my burette with the titrant with a little amount. I don't wash with 50 milliliter or with 100 milliliter. It will be a waste. Now I am sure that I have rinsed the burette very well. I close its top and I look well. If I have some air bubble inside, it is clear that I have no air bubble inside the burette. I fill it till the mark and I adjust the mark of the burette to start the titration. So I fill little bit above the mark. I remove the funnel because there must be here 2 or 3 drops of the titrant. I have to remove the funnel. Then I adjust the mark of the burette. Okay. Now I will start to titrate M1. This is the Erlenmeyer noted one. I will shake a little bit to dissolve the sodium oxalate granules. I surely can insert some magnet bar by tilting the Erlenmeyer flask and inserting the magnet bar. I have to put the Erlenmeyer at the center of the stirrer and I have to adjust the burette accordingly. I put the Erlenmeyer at the center. I turn the stirrer on and I adjust the burette accordingly. For the reaction between sodium oxalate and KMnO4 to occur, we need to heat the solution. The reaction will not be complete at room temperature. That's why I have to put the heater on almost at little bit more than 100, as now the solution is at room temperature, which is 24 degrees. I have to wait little bit till the solution reaches 40 degrees. Then I will have to lower the heating rate of the machine to restart the experiment at 50 degrees. First, I have to pour 30 milliliter of my solution. So now I have started the titration. I will stop to add the solution at 30 milliliter of KMnO4. So I'm adding one shot, 30 milliliters of KMnO4. The solution is now at room temperature. I will wait until the solution reaches almost 50 degrees to continue my titration. Now, if I look at the thermometer that I have inserted, I see the temperature of the solution is almost 38 degrees. If you look well at the color of your solution, it is clear that the color will disappear soon. Its color is changing. Is it clear for you? Look well. The color now is changing from purple to dark red. Can you see the difference in color here? This is purple. This is the color of the original solution. Now dark purple, dark red, and now it will become light red, orange, and the color will disappear. It means what? It means that the KMnO4 is reacting with sodium oxalate at 40 degrees, but we have to wait a little bit till almost 50 degrees to be sure that the reaction will be a complete reaction. The temperature is now 50 degrees. I will remove the thermometer. I will decrease the heating rate to 50, and I will continue the titration. I will continue because I have started the titration, but this time I will continue it drop-wise because I don't know the equivalency at which volume it will occur. I will go drop-wise. The pink color is appearing and disappearing. Of course, this reaction did not need an indicator because KMnO4 is colored, and the equivalency will be clear when the solution becomes pink. The volume is now almost 35 milliliters. I continue till the pink color appears in the solution, and thus I know that I have reached the equivalent point. The volume is now 37 milliliters. I keep my hand on the top of the burette because I may need to close it. My eye on the color and my hand on the top of the burette. The color is taking more time to disappear. The color is taking a long time to disappear. I think now I have reached it. Yes, the color did not disappear. So this is the equivalent point of M1. I go to the burette and look at the volume. The volume is 40. Now, as the burette is graduated from up to down, so I have to read 0, 10, 20, 30, 40, 41, 42, 43.5 milliliters. I note on the report sheet for M1, the volume is VE1 is 43.5 milliliters. Now I have to do the titration of the second weight of sodium oxalate following same procedure, the Fuller-Bright procedure, same procedure. So I have to fill again the burette till the mark and transfer the magnet bar into the second Erlenmeyer flask to titrate it. We will start to titrate now the second weight of sodium oxalate, which we named M2. We place the Erlenmeyer flask at the center of the stirrer. We turn the stirrer on and we pour 30 milliliters of our titrant. (30 milliliters, one shot). So those are 30 milliliters. I insert the thermometer. Now the solution is at room temperature. And I turn the heater on. I will wait for the solution to reach 50 degrees to continue the titration. The temperature now is 38 almost, so the color will disappear soon. It is changing from purple till dark red, till light red, orange, and then it will disappear. It is becoming red. Light red, and it will disappear. Now the temperature is almost 40 degrees. And we have to wait until the temperature reaches 50 degrees to continue the titration. The temperature is now 50 degrees. I remove the thermometer, I lower the heating rate, and I can continue my titration. I can go a little bit faster than the first one as I know almost the needed volume of titrant. This is the second sample of sodium oxalate for the standardization of KMnO4. Now the volume is 38 milliliters. I have to keep my hand on the top of the burette and my eye on the color of the solution. I'm going a little bit slower than before because the volume is now 39 milliliters. Of course, M1 is different than M2, so basically I have to get a different volume than VE1. I am very close. I think this is the equivalent point. The color is a little bit pinkish. Can you see it? So now I am done with the second titration and I can turn the heaters and the stirrer off. and I will get the volume from the burette. If I go to the burette, I can read now VE2 43 milliliters. So for M1 I have VE1, for M2 I have VE2. And I am done with the standardization step. Now I have to titrate with the same Fowler-Bright procedure an unknown weight of sodium oxalate. So I have again to refill the burette, to put the unknown weight of sodium oxalate into a clean Erlenmeyer flask, and I have to add 250 milliliter of H2SO4. Same procedure as I did for the 2 samples of sodium oxalate of the standardization. The only difference is before I knew M1 and M2, but this time I don't know the weight of the sodium oxalate. So I will add 250 milliliter of the diluted acid that I have prepared to the unknown weight of sodium oxalate and titrated following the same Fowler-Bright procedure. This is the unknown weight of sodium oxalate. I insert the magnet bar, I put it on the stirrer, I turn the stirrer on and the heater on, I pour 30 milliliters, so I have to follow exactly the same procedure as before. Because I have same compound, sodium oxalate and KMnO4, the only difference is that I don't know the weight that I'm going to standardize. That's why I will go later on dropwise when I will continue the titration at 50 degrees. I have to go dropwise. So now I have added 30 milliliter of KMnO4. I turn the heater on. I insert the thermometer and I have to wait for the solution to reach 50 degrees. Color is disappearing now. The temperature is 38 degrees. And you have complete disappearance of the KMnO4 color inside the Erlenmeyer flask. We will wait until 50 to continue the titration. The temperature is now 50 degrees. We remove the thermometer, we lower the heating of the heater, and we continue our titration dropwise. I think that we have reached the equivalency, but we will wait a few seconds to see if the color will persist or not. Yes, the color is persisting, so I turn the heater off, I turn the stirrer off, and I look at the burette and I can read it is 36.9 milliliters. So I will write on my report sheet titration of unknown oxalate, VE equals 36.9 milliliters. And now I have all the data to do all the calculations and to complete my report sheet, and we are done with our today's experiment.